The universe is vast, and as we discover more about it, we realize that our little corner of space, Earth, is pretty ordinary and comfortable. We're fortunate to be in a calm area. However, there are many parts of space with strange and sometimes violent things, like super-hot stars, planets as fluffy as cotton candy, and galaxies that have been around since the early days of the universe. These cosmic objects are fascinating, even if they might not be the most extreme for very long. Oumuamua is the first confirmed object from another star to visit our solar system. This interstellar interloper appears to be a rocky, cigar-shaped object with a somewhat reddish hue. Oumuamua was discovered on October 19, 2017, by the University of Hawaii's Pan-STARRS-1 telescope, funded by NASA's Near-Earth Object Observations (NEO) program, which finds and tracks asteroids and comets in Earth's neighborhood. While originally classified as a comet, observations revealed no signs of cometary activity after it slingshotted past the Sun on September 9, 2017, at a blistering speed of 196,000 miles per hour, 87.3 kilometers per second. It was briefly classified as an asteroid until new measurements found it was accelerating slightly, a sign it behaves more like a comet. The object was named Oumuamua by its discoverers. It means a messenger from afar arriving first in Hawaiian. Oumuamua is up to 1/4 mile, 400 meters, long and highly elongated, perhaps 10 times as long as it is wide. That aspect ratio is greater than that of any asteroid or comet observed in our solar system to date. While its elongated shape is quite surprising, and unlike objects seen in our solar system, it may provide new clues into how other solar systems form. The observations suggest this unusual object had been wandering through the Milky Way, unattached to any star system, for hundreds of millions of years before its chance encounter with our star system. Immediately after its discovery, telescopes around the world, including ESO's Very Large Telescope in Chile, were called into action to measure the object's orbit, brightness, and color. The urgency for viewing from ground-based telescopes was vital to get the best data. Combining the images from the 4S instrument on the ESO telescope using 4 different filters with those of other large telescopes, a team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii found that Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. No known asteroid or comet from our solar system varies so widely in brightness, with such a large ratio between length and width. The most elongated objects we have seen to date are no more than 3 times longer than they are wide. According to Meach, this unusually big variation in brightness means that the object is highly elongated, about 10 times as long as it is wide, with a complex convoluted shape. He also found that it had a reddish color, similar to objects in the outer solar system, and confirmed that it is completely inert, without the faintest hint of dust around it. These properties suggest that Oumuamua is dense, composed of rock and possibly metals, has no water or ice, and that its surface was reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years. A few large ground-based telescopes continued to track the fading object as it receded from our planet. 2 of NASA's space telescopes, Hubble and Spitzer, tracked the object traveling about 85,700 miles per hour, 38.3 kilometers per second, relative to the Sun. Its outbound path is about 20 degrees above the plane of planets that orbit the Sun. The object passed Mars's orbit around November 1st and will pass Jupiter's orbit in May of 2018. It will travel beyond Saturn's orbit in January 2019. As it leaves our solar system, Oumuamua will head for the constellation Pegasus. Preliminary orbital calculations suggest that the object came from the approximate direction of the bright star Vega in the northern constellation of Lyra. However, it took so long for the interstellar object to make the journey, even at about 59,000 miles per hour, 26.4 kilometers per second, that Vega was not in that position when the Oumuamua was there about 300,000 years ago. Astronomers estimate that an interstellar object similar to Oumuamua passes through the inner solar system about once per year, but they are faint and hard to spot and have been missed until now. It is only recently that survey telescopes, such as Pan-STARRS-1, are powerful enough to have a chance to discover them. The debate over the origins and molecular structure of Oumuamua continued today with an announcement in the Astrophysical Journal letters that despite earlier promising claims, the interstellar object is not made of molecular hydrogen ice after all. The earlier study, published by Seligman and Laughlin in 2020, after observations by the Spitzer Space Telescope set tight limits on the outgassing of carbon-based molecules, suggesting that if Oumuamua were a hydrogen iceberg, then the pure hydrogen gas that gives it its rocket-like push would have escaped detection. But scientists at the Center for Astrophysics Vertical Bar, Harvard and Smithsonian, CFA, and the Korea Astronomy and Space Science Institute, KSE, were curious whether a hydrogen-based object could have journeyed from interstellar space to our solar system. The proposal by Seligman and Laughlin appeared promising because it might explain the extremely elongated shape of Oumuamua and the non-gravitational acceleration. However, their theory is based on an assumption that H2 ice could form in dense molecular clouds. If this is true, H2 ice objects could be abundant in the universe, and thus would have far-reaching implications. H2. Ice was also proposed to explain dark matter, a mystery of modern astrophysics, said Dr. Thiem Huang, senior researcher in the Theoretical Astrophysics Group at KSI, and lead author of the paper. We wanted to not only test the assumptions in the theory, but also the dark matter proposition. Dr. Avi Loeb, Frank B. Baird, professor of science at Harvard, and co-author on the paper, added, "We were suspicious that hydrogen icebergs could not survive the journey, which is likely to take hundreds of millions of years, because they evaporate too quickly, and as to whether they could form in molecular clouds. An accepted astrophysical origin for solid objects is growth by sticky collisions of dust. But in the case of a hydrogen iceberg, this theory could not hold together. An accepted route to form a km-sized object is first to form grains of micron size, then such grains grow by sticky collisions," said Huang. However, in regions with high gas density, collisional heating by gas collisions can rapidly sublimate the hydrogen mantle on the grains, preventing them from growing further. Although the study explored the destruction of H2 ice by multiple mechanisms, including interstellar radiation, cosmic rays, and interstellar gas, sublimation due to heating by starlight has the most destructive effect. And according to Loeb, thermal sublimation by collisional heating in GMCs could destroy molecular hydrogen icebergs of Oumuamua size before their escape into the interstellar medium. This conclusion precludes the theory that Oumuamua journeyed to our solar system from a GMC, and further precludes the proposition of primordial snowballs as dark matter. Evaporative cooling in these situations does not reduce the role of thermal sublimation by starlight in the destruction of H2 ice objects. Oumuamua first gained notoriety in 2017 when it was discovered screaming through space by observers at Haleakala Observatory, and has since been the subject of ongoing studies. According to Huang, this object is mysterious and difficult to understand because it exhibits peculiar properties we have never seen from comets and asteroids in our solar system. Two Arizona State University astrophysicists, Stephen Desch and Alan Jackson of the School of Earth and Space Exploration, set out to explain the odd features of Oumuamua and have determined that it is likely a piece of a Pluto-like planet from another solar system. Desch, a professor in the School of Earth and Space Exploration, said that Oumuamua resembled a comet, but it was peculiar enough in several ways that mystery surrounded its nature, and speculation ran rampant about what it was. From observations of the object, Desch and Jackson determined several characteristics of the object that differed from what would be expected from a comet. In terms of speed, the object entered the solar system at a velocity a bit lower than would be expected, indicating that it had not been traveling in interstellar space for more than 1 billion years or so. In terms of size, its pancake shape was also more flattened than any other known solar system object. They also observed that while the object acquired a slight push away from the sun, a rocket effect common in comets as sunlight vaporizes the ice they are made of, the push was stronger than could be accounted for. Finally, the object lacked a detectable escaping gas, which is usually depicted visibly by a comet's tail. In all, the object was very much like a comet, but unlike any comet that had ever been observed in the solar system. Desch and Jackson then hypothesized that the object was made of different ices, and they calculated how quickly these ices would sublimate, passing from a solid to a gas, as Oumuamua passed by the sun. From there, they calculated the rocket effect, the object's mass and shape, and the reflectivity of the ice. They realized that a chunk of ice would be much more reflective than people were assuming, which meant it could be smaller. The same rocket effect would then give Oumuamua a bigger push, bigger than comets usually experience. Desch and Jackson found one ice in particular, solid nitrogen, that provided an exact match to all the object's features simultaneously. And since solid nitrogen ice can be seen on the surface of Pluto, it is possible that a comet-like object could be made of the same material. They then calculated the rate at which chunks of solid nitrogen ice would have been knocked off the surfaces of Pluto and similar bodies early in our solar system's history, and they calculated the probability that chunks of solid nitrogen ice from other solar systems would reach ours. It was likely knocked off the surface by an impact about 500 million years ago and thrown out of its parent system, Jackson said. Being made of frozen nitrogen also explains the unusual shape of Oumuamua. As the outer layers of nitrogen ice evaporated, the shape of the body would have become progressively more flattened, just like a bar of soap does as the outer layers get rubbed off through use. Could Oumuamua have been alien technology? Although Oumuamua's comet-like nature was quickly recognized, the inability to immediately explain it in detail led to speculation that it is a piece of alien technology, as in the recently published book, Extraterrestrial: The First Signs of Intelligent Life Beyond Earth, by Avi Loeb of Harvard University. This has sparked a public debate about the scientific method and the responsibility of scientists not to jump to unwarranted conclusions. According to Desch, everybody is interested in aliens, and it was inevitable that this first object outside the solar system would make people think of aliens. But it's important in science not to jump to conclusions. It took 2 or 3 years to figure out a natural explanation, a chunk of nitrogen ice, that matches everything we know about Oumuamua. That's not that long in science, and far too soon to say we had exhausted all natural explanations. Although there is no evidence that it is alien technology as a fragment of a Pluto-like planet, Oumuamua has provided scientists with a special opportunity to look at extrasolar systems in a way that they have not been able to before. As more objects like Oumuamua are found and studied, scientists can continue to expand our understanding of what other planetary systems are like and the ways in which they are similar to or different from our own solar system. Desch and Jackson hope that future telescopes, like those at the Vera Rubin Observatory, Large Synoptic Survey Telescope in Chile, which will be able to survey the entire southern sky on a regular basis, will be able to start finding even more interstellar objects that they and other scientists can use to further test their ideas. Discovering there's intelligent life beyond our planet could be the most transformative event in human history. But what if scientists decided to collectively ignore evidence suggesting it already happened? That's the premise of a new book by a top astronomer, who argues that the simplest and best explanation for the highly unusual characteristics of an interstellar object that sped through our solar system in 2017 is that it was alien technology. Loeb, 58, lays out the argument for the alien origins of the object named Oumuamua, Scout in Hawaiian. In Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, the facts are as follows. But here comes the big question: is Oumuamua an asteroid or a comet? Astronomers expected the first interstellar object they'd discover would be an alien comet. This is because comets orbit in the outskirts of star systems, and stars pass relatively near each other somewhat frequently. So, when two stars fly by each other, the gravitational interaction can rip comets from their loosely tethered orbits, flinging them out into space. This ejection mechanism was further supported last year when astronomers discovered the interstellar comet 2I/Borisov, which looks reassuringly like the dirty snowballs found in our own solar system. It also exhibited a conventional cometary tail, the extended fuzzy line of sublimated gas and ice that streams from comets as they approach the sun. But Oumuamua left astronomers with more confusing hints about its nature and history. Instead of growing an icy tail, this alien space rock looked relatively dry. It also appeared surprisingly dense and rocky. Its shape was even more perplexing. Most space rocks in our solar system are shaped something like a potato, or in the case of Arakoth, like two of them smashed together. But Oumuamua is long and stretched out, more like a cigar. However, the debate still continues as Karen Meach, an astronomer at the University of Hawaii who has studied Oumuamua but wasn't involved in this research, says she still believes the space rock has to be a comet. Part of why she thinks that is because one piece of evidence hinting that the space rock is an asteroid could simply be a dearth of observations. She points out that Oumuamua's high-speed trip through the solar system was too quick for astronomers to get a detailed look at the object. Most of the observations of Oumuamua had to occur within 1 week, And we simply could not detect water, she says. That isn't a lack of water, we just didn't have the sensitivity to see it. She said that there's another outstanding property these researchers still need to explain. Oumuamua's movement through our solar system implied it was being driven by more than just gravity, like a comet whose direction is slightly changed by the force of gases streaming off of it. I think it is a comet, Meech says. The non-gravitational motion that our group detected was super strong, and there's no other way to maintain it except for outgassing. There's no other explanation. Because of Oumuamua's incredible speed, even the fastest spaceship humanity has ever built, NASA's Parker Solar Probe, couldn't catch it. As quickly as it came, the alien interloper was gone, never to be seen again. Thanks for watching this video, and see you next.